So, good morning students. In the last class we discussed about the properties of aldehydes and ketones, okay, chemical properties. So in the today's class we are going to discuss with the preparation, because nomenclature I already studied in the before video. So I will directly go with the preparation of carboxylic acid. Okay. So in this preparation of carboxylic acids, 5 types are there. The first one, oxidation of alcohols. Second one, from acid halides, anhydrides. I'll take here acid halides, anhydrides, and esters. First one is from the oxidation of alcohols. Second one is from acid halides, anhydrides, and esters. In this, the process is hydrolysis. Hydrolysis of acid halide, hydrolysis of acid anhydrides, and hydrolysis of esters. And the third one is from Grignard reagent. From Grignard reagent. Okay, so fourth one is from nitrides. Okay, from nitrides. Next, oxidation of alkyl benzene. Okay, alkyl benzene. Okay, so these are the 5 steps of preparation of carboxylic acids. What are these? Oxidation of alcohols means from alcohols, from acid halides, anhydrides, esters, and also from Grignard reagent, from nitrides, and from alkyl benzenes. So we will discuss with one by one. So first one, the oxidation of alcohols. Okay, so students remember, alcohols means OH is the functional group, and from OH we have to convert into carboxylic acid, COOH group. Understand? So here I will take a primary alcohol. I take RCH2OH. This is what? Primary alcohol. Okay. So when this primary alcohol undergoes oxidation, and this primary alcohol undergoes oxidation in presence of KMNO4. This is what? Oxidizing agent. They form, listen, RCOOH plus H2. This is what? Carboxylic acid. What happens here? One thing, the removal of hydrogen is taking place from this carbon. At the same time, oxygen is added to this carbon. So addition of oxygen and removal of hydrogen, nothing but oxidation. So oxidation of alcohol here. So how can you write? When alcohol, especially you take primary alcohol. Okay? When primary alcohol undergoes oxidation when treated with acidic KMNO4. Okay, remember here, this must be a acid. Acid means KMnO4 must be in the acidic medium because in the acidic medium it is in +1 oxidation state, in the basic medium it changes to +2 oxidation state, and it requires the changes in state. In acidic medium it oxidizes. Okay, so when primary alcohol undergoes oxidation, when treated with acidic KMnO4 forms carboxylic acid. This is the reaction. Okay. Okay. So if you take example, this R is replaced by any CH3 or any benzene. Okay. I'll take here example 1. So in the place of R, I'll take CH3, CH2, OH. So this is what? Ethanol undergoes oxidation in presence of acidified KMnO4. This H plus represents what? Acidified. You take here, in the place of acidic, you take acidified. KMnO4 gives CH3, COOH plus H2O means ethanoic acid. This is the example. So then how can you write? When explanation. In the place of primary alcohol, you have to take ethanol. Undergoes oxidation when treated with acidified KMnO4 forms. In the place of carboxylic acid, you have to take ethanoic acid. So here, when ethanol undergoes oxidation, ethanol undergoes oxidation when it is treated with acidified KMnO4 forms ethanoic acid. So this is the explanation for this. This is the general explanation I wrote here. In the place of primary alcohol, replace ethanol. In the place of carboxylic acid, replace ethanoic acid. So this is what the R group is what? The aliphatic group, like alkyl, CH3, C2H5, C3H7, like that. So if you take example 2, okay, so if benzene ring attached to CH2, further attached to functional group. So this group, benzene ring with the CH2 is called as benzyl. Okay, this is benzyl alcohol. When benzyl alcohol undergoes oxidation, when it undergoes oxidation, when it is treated with acidified, H plus represents acidified, KMnO4 forms this structure COOH, that is benzoic acid. Right here, right, benzenoic acid also and benzoic acid. So can I write the benzyl alcohol undergoes oxidation when treated with acidified KMnO4 forms benzoic acid. That is how to replace the definition. So this is the general reaction. This is the example for alkyl compound, means alkyl substituents. This is for aromatic substituents. Okay, no matter here any other CH3 is there, here any other further groups are there, only the reaction taking place here. So CH2OH and must be a primary alcohol. Then only we can remove H2. So this is the first preparation of carboxylic acid from the oxidation of alcohols. First method, this one. Okay. So the next is from okay. Second one is hydrolysis of acid halides. Okay. Next, acid anhydrides and esters. Hydrolysis means addition of water molecule. So remember here. So I will do the first acid halide. The formula of acid halide is RCOCX. Acid halide formula is RCOX. Okay. Let me write it clearly. This is acid halides. Okay. So this type of acid halides undergoes what? Hydrolysis, means addition of water molecule. Then they gives carboxylic acid and further byproducts. So I check the example here. RCOX. So this is what? Acid halide. So undergoes hydrolysis. Water molecule is going to hydrate in the presence of acid. Any acid, either H2SO4 or HCl. Then what happens? They form RCOOH plus HX. Means this H2O this changes to H plus and OH minus. This X is replaced by OH plus minus charge. Okay, this X is combined with this H plus forms HX. This is the reaction happen. Okay. So this one is what? Carboxylic acid. So students, how can you write here? When acid halide undergoes hydrolysis in presence of H2SO4 or HCl gives carboxylic acid along with water. This is the explanation. When acid halide undergoes hydrolysis in presence of H2SO4 and HCl, H plus ion, it requires, gives carboxylic acid. Here the product. This is the general reaction from acid halide. Okay? So remember, if you take any example, the Ra I can replace by this C and CO and it is Cl. Acid halide. Okay, you may take it as acyl chloride also. Acetyl chloride. That is simply called as acyl chloride. Understand? Next, in the case of that, if you take this benzene ring, this is benzoyl chloride. This is acyl chloride. This one is benzoyl chloride. Most of the Chloride compounds only stable in this type of chlorides, means acid halides. Chlorides are highly stable than bromide, fluoride and iodide. Fluoride cannot be possible, bromide can possible, iodide can possible, but the most stable is chlorides. Okay, so when they undergoes hydrolysis, so in presence of what? Acid. H plus means acid. So this one will form CH3 COOH plus HCl. So along with hydrogen halide. I wrote water, it's not water, it's hydrogen halide. So it forms HCl. This one is what? Ethanoic acid. One example. So here, in the place of acyl, you may take acetyl because the CH3 is a acetyl group. Okay, so this is simply called as acyl. When acyl chloride, here acid halide means acyl chloride, undergoes hydrolysis in presence of H2SO4 or HCl, gives carboxylic acid. Which acid? Ethanoic. Just carboxylic acid is replaced by ethanoic acid. Means here, when acyl chloride undergoes hydrolysis in presence of H2SO4 or HCl, gives ethanoic acid along with hydrogen halide, means hydrogen chloride. Okay, so here benzoyl chloride is there. Same, it undergoes oxidation. So hydrolysis in presence of acid. Then what happens? It forms this one is what? Benzoic acid. Okay, so here you can write when benzoyl chloride undergoes hydrolysis in presence of H2SO4 or HCl, gives benzoic acid along with hydrogen chloride. This is how to read this. This is what? From hydrolysis of acid halide. This is the general reaction. These two are the example 1 and example 2. Okay? Next. Second one is from acid anhydride. Formula R C double bond O C double bond O R. That is acid anhydride. So students, I take the general reaction R C double bond O C double bond O R. So when they undergoes hydrolysis in presence of acid. Listen here. Here they are divided into like this. RCOO minus and SARCO plus. So here H2O is there. One H is attached here, another OH is attached here. So two molecules of. So listen here. This one is R C double bond O OH. Correct? Plus you take this one here, R dash C double bond OH. So students, this is great like this means here I write R C double bond O minus, and this one is R dash C double bond O plus. So this hydrogen is H2 is dissociated as H plus and OH minus. So this one is dissociated as H plus and OH minus. Here it is in minus charge, so H plus is goes here, forms RC double bond OH. Here RC double bond plus is there, OH is going to attach here, plus is there, minus will attach, minus is there, plus will attach. So it will also come R dash C double bond OH. Means this R group may be same, may not be same. Both are same or not same, are different. Okay. So this is how the reaction takes place. So students, this is acid anhydride. This is nothing but carboxylic acids. Both are carboxylic acids. So here you write one acid anhydride undergoes hydrolysis in presence of H2SO4 and HCl gives carboxylic acid. So this is the explanation. Understood? When acid anhydride undergoes hydrolysis in presence of H2SO4 or HCl gives carboxylic acid. So here I'll take the example 1. CH3, C double bond O, C double bond O, CH3. This is what? Acetic anhydride. Acetic anhydride. So it undergoes hydrolysis in presence of H plus. So you complete yourself and give 1 minute for everyone. CH3, C double bond O, C double bond O, CH3. What are the products formed here? What are the products formed here? One is CH3COOH, another is also CH3COOH, because here both the R groups are same. Okay, so instead of this, if you take H5 here, one is CH3COOH, another one is C2H5COOH. Understood? So this is the reaction. This is what? Ethanoic acid. So this type of anhydride cannot be possible in benzene ring because this double bond is involved in the resonance, so that becomes highly unreactive. That's why like this type of compound, benzene ring with this C double bond O, C double bond O, and benzene ring cannot be possible. So this is unstable. Okay, that's why I am not taking the example of aryl compound here. Only alkyl compound I will take. Next one is from ester. So ester formula is R C double bond O OR. Okay, so take here R C double bond O OR undergoes hydrolysis in presence of acid. So remember one thing, if we want to add water molecule, we have to take dilute acids. Remember that. Addition of water molecule means dilute acid, dilute H2SO4, dilute HCl. Removal of water molecule, dehydration means we have to take concentrated acid, especially concentrated H2SO4. So here what happens? This is H plus and OH minus. Understood? H plus and OH minus. Here it just dissociated. So this will get plus charge, this will get minus charge. Okay, then you remember. So if this is dissociated as H plus and OH minus is attached here. So C double bond OH and H plus is going to attach like R. So one is carboxylic acid, another one is alcohol. So this is what ester. Okay. When ester undergoes hydrolysis in presence of acids, which type of acids? Dilute acids, gives carboxylic acid and alcohol. Remember students, it is a reversible reaction if we use this concentrated H2SO4. Listen, when this RC double bond OH reacts with carboxylic acids reacts with alcohol in presence of concentrated H2SO4, removal of water molecule takes place and they form ester from the water molecule. The reversible reaction is the esterification reaction, which is important for 2 marks. I'll explain in the chemical properties of carboxylic acid. This reaction is exactly reversed. But the thing is what? Reactants is this, product is this. Instead of dilute, we have to take concentrated. Esterification reaction. In the next class, I'll explain. Okay, there what happens? Removal of water molecules, so we have to use concentrated acids. So here what happens? When, just you have to replace, when esters undergoes hydrolysis in presence of H2SO4 or HCl gives carboxylic acid along with alcohol. Understood? So if you take example 1, take acetic acid. Sorry, this one is methyl acetate. Methyl acetate or methyl ethanoate. Right here, this is methyl ethanoate. Undergoes hydrolysis in presence of H plus gives CH3 C double bond OH plus CH3 OH. This is ethanoic acid and this one is methanol. So students here, how can you write means when methyl ethanoate ester undergoes hydrolysis in presence of H2SO4 or HCl gives ethanoic acid in the place of carboxylic acid and along with alcohol means methanol. This is the explanation. So in the place of this, if you take a benzene ring, as I told you, 2 benzene rings cannot be possible. Okay, this is methyl benzoate. Understood? This is what? Methyl benzoate. Undergoes hydrolysis. Reaction is same, only the reagent is different. So forms this one, benzoic acid and methanol. So this one is benzoic acid, of course this one is methanol. Okay, so how can we explain here? When this methyl benzoate undergoes hydrolysis in presence of H2SO4 or HCl gives benzoic acid and along with alcohol, that is methanol. This is the examples. This is what? From esters. So this both aldehydes, anhydrides and esters form carboxylic acid upon hydrolysis. So this acid aldehyde form carboxylic acid along with hydrogen atoms. This one 2 carboxylic acid. This one carboxylic acid and the alpha. Remember. Okay. So in that this reaction is important and the reverse of this reaction is also important. Esterification reaction. So the next one is from Grignard reagent. So students remember, if I wrote the general reaction means you should take any R group by any alkyl or aryl group. So if I take particular reagent in a particular reaction means you have to use the same reagent. For example, as I told you in the last class, in the Canizerose reaction, of course, so many alpha absent aldehydes are there. Alpha hydrogen means so many aldehydes which are not having alpha hydrogen. Then only we have to take either benzaldehyde or formaldehyde. Understand? In the Canizerose reaction, in aldol condensation, we have to take the aldehydes and ketones which are having alpha hydrogen. So means particular, for if named reactions are there, for that named reaction, particular reagent is also there. If there is no named reactions, it is like that from alcohols, from feed. Okay, they are general. Then you have to take any one of the example. Just remember, for all you cannot take. Woods reaction, as I told you, the general reaction is there for Woods reaction. Okay, Rx plus 2Na gives rise to RR. Then you may take that. But Woods reaction means you have to take only alkyl. Fitting means you have to take only aryl. Woods fitting means one alkyl, one aryl. That type of concept you have to understand. Once you understand that, you need not to work again and again. Once you understand the concept. So listen here. So why I am writing the general reactions along with the example here? In the examination, they told you to choose example of your own choice. Means how can they say? Explain esterification reaction with an example. When they ask with an example, you cannot write the general reaction. By taking any example, you have to write. Like that they will ask. Example of your own choice. They won't mention any particular reagent. Understood? Next one is from Grignard reagent. So students, Grignard reagent means RMGX type compounds. Okay. So listen. So initially, this Grignard reagents reacts with carbon dioxide. Carbon dioxide form is what? Here I take. So carbon dioxide is written as C double bond O double bond O. You know that carbon dioxide structure. Correct? So listen here. What happens? Here this bond will break and here another bond will form. How? So listen. Just I am for convenience I am writing like this. Don't write it. This is CO2 only like this. How the reaction takes place? Here double bond O is there. Here single bond is there. Here also single bond will form. So this is going to attach this R, C double bond O, O, and later it is MgX. This is how the CO2 is inserted in that Grignard reagent. So when the Grignard reagent is treated with carbon dioxide, they form this type of adduct. Adduct means additional product. This is an adduct. It is not stable. Adduct means additional product. So upon hydrolysis means reaction with water. So these one is so listen, R, C double bond O, OH. Here OH is attached here. So the remaining is Mg, OH, X. Are you getting? RC double bond O OH and RC double sorry MgOH magnesium hydroxide halide. Okay, this is the reactant form. So listen, in the place, this is the general reaction. This is what Grignard reagent. Okay, this is of course carbon dioxide. This is the other, and this one is carboxylic acid. Okay, so next, how can you write here? One, sorry, not one. Grignard reagents reacts with solid CO2. Means what? Solid CO2 means dry gas. Sorry, dry ice. Solid CO2 means dry ice. Okay? When Grignard reagents react with dry ice, you may write, or solid CO2 followed by hydrolysis gives carboxylic acid. Okay, so this is what Grignard reagent reacts with solid CO2 followed by hydrolysis gives carboxylic acid. So this is the product. There is no particular name for this, so we can directly write the complete reaction. So I'll take the example here. That is methyl magnesium bromide unit. Methyl magnesium bromide. Remember, so Grignard reagent may be formed by bromide, chloride, iodide, but not by fluoride. Means methyl magnesium fluoride cannot be possible because fluoride cannot form Grignard reagent. Only chloride, bromide, iodides are present. Okay, I'll take the example of methyl magnesium bromide. So in here I write X may be Cl, Br, I. Remember that. Okay, so CH3Mg plus CO2. You may directly write CO2 here. Then they form CH3, C double bond O, O, Mgx. So upon hydrolysis, they form CH3, COOH plus MgOH Br. Okay, so this one is what? Ethanoic acid. This is what? Methyl magnesium bromide. Okay, so when methyl magnesium bromide reacts with solid carbon dioxide followed by hydrolysis gives ethanoic acid. This is the reagent. And remember, here you cannot take aryl compound, benzene ring, because Grignard reagent is only alkyl magnesium halides, not aryl magnesium halides. So you cannot take, okay, R only alkyl group. And X is Cl, Br, I. This is the condition. You cannot take R as an aryl compound, means benzene ring, because as I told you, Grignard reagent means the scientist Grignard discover this type of reagents. So that is only made up of what? Alkyl compounds, not benzene ring. Understood? You may take CH3 here, C2H5, C3H7, whatever you may be take. But that must be an aliphatic, not aromatic. Alkyls. Okay? So this is what? The preparation of carboxylic acids from Grignard reagent. So the next one is nitrites. Nitrides means RCN compounds. Okay. Same students, listen. So initially, this RC triple bond N compounds undergoes hydrolysis. Listen, here what happens? This H2 goes here. Means listen, R is there, double bond O, single bond NH2. This is how the reaction takes place. C double bond O and NH2. Remember why? Listen here, carbon is there, nitrogen is there. Among carbon and nitrogen, which one is highly electronegative? Means this one. The electrons are shifted towards this. So C triple bond N is there. If one bond breaks, one electron less here, another electron goes here. So if another one breaks, another positive charge here, another negative charge here. Just an assumption. The reaction cannot take place like this. Okay. So here two positive charges will form. Here two negative charges. H2O is dissociated with OH plus O2 minus. So that's why oxygen is attached here. Hydrogens are attached here. Because they have plus charge, minus charge. This is minus charge, this is plus charge. Just a simple thing to understand. Okay. Of course, the mechanism cannot be like this. Just for your convenience, understanding I am telling. So upon further hydrolysis. Okay. Upon further hydrolysis, what we require? Carboxylic acid. So here, breaking will take this R C double bond O OH. Remaining is what? NH2. Here H. They will form NH3. Means the breaking will take place here. Like C double bond O plus NH2 minus. Then they form RC double bond O OH and NH3. So this is amide. So this is nitrides. Especially alkyl nitrides. Alkyl nitrides, amide and carboxylic acid. This is ammonia. Okay, so listen, here we can mention this name of the compound. So right here, alkyl nitrides undergoes hydrolysis, gives amides. Okay. Upon further hydrolysis, they form carboxylic acid and ammonia. So this is the explanation. Alkyl nitrides undergoes hydrolysis is amides. This one. Upon further hydrolysis gives carboxylic acid and ammonia. So this is what? Preparation of carboxylic acids from nitrides. Okay. So you may just replace this R group. CH3, C triple bond N. That is what? Methyl nitride. Undergoes hydrolysis, gives CH3, C double bond O, NH2. Here two carbon atoms are there. Correct? So that is ethanamide plus H2O gives rise to CH3, C double bond O, OH plus NH3. This is ethanoic acid. So on the right here, when methyl nitride undergoes hydrolysis gives ethanamide. Upon further hydrolysis they form ethanoic acid. This is the explanation. Understand? Only alkyl nitriles will react, not aryl nitriles. You cannot take benzene ring here also. Understand? So the last one is oxidation of alkyl benzene. They specifically mention alkyl benzene means to the benzene ring, alkyl groups are going to attach. Alkyl means it may be CH3, C2H5, C3H7, etc. Okay, so what is this reagent? Okay, listen. So I'll write the reaction first. And take alkyl substituted means methyl. So when methyl benzene undergoes oxidation in presence of alkaline KMnO4. Alkaline KMnO4. Alkaline KMnO4 means in the basic medium alkaline is there. KOH is a base. This is alkaline KMnO4. Gives what? COOH, potassium benzoate. Understand? So when it is further treated with acid or acidified with acid, they form COOH plus KCl. Okay, is that your students? Here COO, two oxygen atoms are inserted. So you take here on H2O we have to remove means 3 moles of O will be required. 3 moles of oxygen. Okay. So this is what the reaction of preparation of carboxylic acid, especially benzoic acid from alkyl benzene. So this one is what? Methyl benzene. This one is alkaline KMnO4. This is potassium benzoate. So this one is benzoic acid. You may write the direct reaction here because they specifically mention alkyl benzene. You have to take only one example. There is no R substitute here. Okay. So here 1 methyl benzene treated with alkaline KMnO4. Alkaline KMnO4 forms potassium benzoate followed by acidification gives benzoic acid. So this is the explanation. Understand? So this is all about the preparation of carboxylic acid by these 5 methods. Okay, so in the tomorrow's class we will discuss with the chemical properties of carboxylic acids. Thank you.